Hi, in today's lesson we're going to be talking about probability using permutations and combinations. It's a short lesson. I hope you enjoyed today's lesson. Let's revisit permutations and combinations. Now we're going to be using permutations and combinations in probability. First we have to review what permutations are. Remember, with permutation, order does matter. And we say if we're going to take n objects and select r of them, in an arrangement, another word for permutation is arrangement, then we're going to have n factorial divided by n minus r factorial. Remember, subtract n minus r and then take the factorial. With combinations, order doesn't matter. It's also known as a selection. We see the symbology as NCR, or sometimes you just see it in parentheses with n over r, and it is equal to n factorial divided by n minus r factorial, just like the permutation, but the extra step is to include this r factorial in the bottom. You can see for the same numbers, where order does matter in a permutation, our fraction, our total answer will be greater than here because we're dividing, with a combination, we're dividing by r factorial. Here is a first example of using permutations and combinations in probability. 3 math books, 3 chemistry books, and 2 physics books. We have 3 and 3 and 2, so that's a total of 8 books. Are to be arranged. Arranged, you're thinking permutation. Order matters. Arranged on a shelf. What is the probability that the 3 math books are together? Well, probability means that we have to have our total sample space in the denominator. We've got 8 books and we're arranging the 8 books. How many ways can you arrange 8 books? 8 factorial. Well, if I consider that I have to, here are the 3 math books. Well, I can move those math books anywhere. But I have to consider the 3 math books 1 unit. If I consider the 3 math books 1 unit, I have 1, 2, 3, 4, 5, 6. I've got 6 different objects. Well, how many ways can I arrange 6 different objects if I consider that 1 unit? 6 factorial. But if I move this 1 unit around in different ways and I can change the order of these 6 objects, within this 1 big unit here, I can switch this one first and that one second and this one third, etc. So how many ways can I arrange 3 different objects? 3 factorial. So this will give me a total answer of, if I simplify this, I'll get 3 out of 28. That's the probability that the 3 math books are together. Here's another example of using permutations and combinations in probability. A committee of 5, so I can only have 5 committee members, is randomly chosen from 8 boys and 6 girls. Find the probability that the committee consists of at least 3 boys. So my committee could be boy, boy, boy. There's at least 3 boys. Or it could be boy, 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 boy. Or it could be boy, 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 boy. That means that my girls could be, in our first committee, it could be girl, girl, or girl. We can either have 3 boys, 4 boys, or 5 boys, leaving us with 2 girls, 1 girl, or 0 girls. Well, what does this committee look like? We're selecting a committee. A committee, it doesn't matter if Johnny comes before Billy or Billy comes before Ted. And it doesn't matter if Susie is before Sarah or Sarah before Susie. We just need to know the names of the girls. So we can do a combination. This is going to be a combination. So if I've got 3 boys and 8 to choose from, I'm going to do 8C3 times, for my girls, I have 6 girls and I have to choose 2. 6C2. And the final answer there, when I do that out, is 840. And in this situation, I've got 4 boys, so I'm going to have 8C4, and I'm going to multiply that by 6 to choose from, and we're only going to select 1. And this gives us a subtotal of 420. And finally, I'm going to do here, it's 8 boys to choose from, and we're going to select 5 times. For the girls, it's 6 to choose from, we're going to just choose 0, and that's going to give us 56. So we get those different answers, 840, 420, and 56, and all we have to do now is add them up. When we add them up, we get 13, 16. So I have 1316 possibilities there? Well, that is the different numbers of committees that satisfy these parameters. Well, we want to find the probability, so we need to know the total number of committees we can have. We've got 8 and 5. I'm sorry, we've got 8 and 6, which is 14. We've got 14 to choose from, and we're only going to select 5. So if we have 14, and we're going to choose only 5, that will give us 2,002 different possibilities. Now, this 2,002, what does that represent? 2,002 is any committee. It's 5 boys, it's 4 boys, it's 3 boys, it's 2 boys, it's 1 boy, it's 0 boys, and that would allow us also to have 5 girls. That's every possible committee is 2,002. We have 14 total, and we're choosing 5, so that's 14C5 gives us 2,002. Well, the committees we're involved with here are only 1316. So what's the probability that we have at least 3 boys? It's going to be 1316 divided by 2,002. And if you do that out, that gives us 0.66. So we have about a 66% chance of getting at least 3 boys.